Okay, so we are doing 37, and we said if it's a division inside a logarithm, we can make that a subtraction. If it's a multiplication inside a logarithm, we can make that an addition. Okay, I can actually keep this going. There's a few things I can do here. These have some powers in it. So this 1/2 can move to the front. This 3 can also move to the front. And this 4, that's a multiplication. We can use our multiplication rule yet again. So we will have the log base 4 of 3 plus 1/2 times the log base 4 of x plus 2 minus, and I'll go ahead and no, I won't distribute this negative. Log base 4 of 4 plus the log base 4 of y plus 3 times the log base 4 of z minus 1. This is my final answer. There's no other multiplication, no other division, no other exponents inside of my logarithm, so I'm done. Do we have any questions about that? Okay. 38, write it as a single logarithm. Okay, the first thing I notice, this one has a 2 in front. I'm going to do the power rule backwards. Log of 3 plus the log of x squared minus the log of 5. These first two are multiplied. We can make them into a multiplication. That last one, we can make it into a division. So it would be like this. The log of 3 times x squared, all divided by 5. It's the same rules, but backwards. Questions? Okay. Solve this. 1 over 64 equals 4 to the 2x plus 1. Okay, well, here's what I know. 64 is 4 cubed. So I'm going to start with that. 64 is 4 cubed. Is that okay? Well, that means 1 over 4 cubed is the same as 4 to the negative 3. For the record, if you had typed into your calculator, this is an exponential form, right? So we could this is route 2, different option. You could also do this. You could say, well, the log base 4 of 1 over 64 is equal to 2x plus 1. That is totally fine. Do you see how we could get from the circled red to that? It's just the rearranging again. That would be totally fine. Your calculator would give you negative 3. I got the same thing. If I've got this, these 4's can basically cancel, and I will have negative 3, 2x plus 1. Same thing. 2 different ways to solve it. Either way is okay. I'm going to put or. Then I'm just going to subtract 1 from both sides. This one will be the same. Divide both sides by 2. I get x equals negative 2. Questions? Okay. 40. 6 plus e to the minus 4x equals 9. I'm going to subtract 6 from both sides. E to the minus 4x equals 3. Then I'm going to rearrange it. It's in exponential form. Let's write it as a logarithm. The log base e. What is the log base e also known as? Do y'all remember? Natural log. So I could write log base e, but most of the time you'll see that as natural log. So the log base e of, 3 is equal to negative 4x. So the log base e of 3 is equal to negative 4x. Then to get x by itself, I divide both sides by negative 4. X equals the natural log of 3 divided by negative 4. And that's it. Questions? I know I'm flying. Okay. Solve this. Well, first thing I'm going to do is divide both sides by 3. You always get rid of the extra stuff first. Log base 2 of 8x equals 10. Now it's just a logarithm. I'm going to rewrite it as an exponential. So the base is 2. The power is 10. 2 to the 10 equals 8x. You can put that in your calculator. But let's see. 2 to the 10 is 4, 8, 16, 32, 64, 128, 256, 5, 612. Something big. Just 2 to, you know what? It's thanks, 1024. Divide both sides by 8, and I get x equals, hang on, that would be 128, I think. You can check on a calculator, but it is. Okay, questions? All right. The trick is, get the logarithm by itself, rewrite it as an exponential. Or, get the exponential by itself, rewrite it as a logarithm. That's the strategy for these kinds of equations. Do we have any questions? Okay. We need to get the logarithm by itself. To do that, we're going to have to combine these. Right now we've got 2 different logarithms. We're going to write them as one. They're subtracted, so that's just a division. But now we've got a logarithm base 3. I forgot to write it, but we've got a logarithm base 3 on both sides. So I can just do 3 to the and 3 to the, and this piece will cancel each other out. And I will have x plus 1 over x minus 3 equals 2. And then there's a lot of ways you could do this. Cross multiply, just multiply both sides by x minus 3. You'll get x plus 1 equals 2, x minus 3, which is x plus 1 equals 2x minus 6. Subtract x from both sides, add 6, I get 7 equals x. Questions? Okay. Same idea. We've got 2 logarithms added. I'm going to write it as a multiplication. This is the log base 2 of x times x plus 7 equals 3. And then that's just the log base 2 of x squared plus 7x. Now it's written as a logarithm. Let's rewrite it as an exponential. So we've got our base is 2, so that means 2 to the power is 3 is equal to x squared plus 7x. 2 cubed is 8. Now it's a quadratic. Let's subtract 8 from both sides. And we're going to factor it. This factors as x minus 1, x plus 8, which means x minus 1 equals 0, or x plus 8 equals 0. So x equals 1, or x equals negative 8. I know I'm going super fast, but I'm hoping that most of that is pretty familiar. Is there anything in there that you want me to go over again? Okay. I'm seeing a lot of blank faces. But we're getting somewhere. We're close. We're getting toward the ends of this. Okay. A couple needs $14,500 for a down payment. They invest $7,250. It is at 5.8% compounded continuously. Okay. How long will it take for it to grow into what they need? Okay. Compounded continuously. That is on the formula sheet that I posted, the PDF under notes. It's a formula that you need to memorize, but it's this. A equals P times e to the RT. Amount equals the principal times e raised to the power of rate times time. What is the amount? 14,500. Yeah. It's the amount that they need. The amount after time has passed. What's the principal? It's this part, the amount they invest, 7,250. So 7,250 times e to the, what's r? 0.058. T is what we're looking for. It's going to stay the same. We okay with that so far? From here, it's the same exact strategy. get the thing by itself. If it's an exponential, write it as a logarithm. If it's a logarithm, write it as an exponential. This is an exponential. We're going to first get it by itself. So I'm going to divide both sides by 7,250. And when I do that, I'm pretty sure it's just 2. I will get 2 equals e to the 0.058t. Then that's an exponential. I can rewrite it as a logarithm. So it'll be the log base e, but again, we don't usually write it like that. We usually write natural log of 2 is equal to 0.058t. Last thing I do is divide both sides by 0.058, and I will have my answer. So t equals natural log of 2 divided by 0.058. Put that in your calculator, it'll give you an answer. Questions? Is this way too fast, or do y'all feel like you're keeping up okay? 50-50? No thoughts? All right. A substance. Oh, look at that. It gives you the equation. That's great. All we're going to have to do is plug stuff in. A0 is the initial amount. T is the time in years. Okay. There are 20 grams present initially. When will there be 12 grams remaining? Well, 12 is the final amount. The initial amount is 20. And then it's e to the negative 0.0047 times t. They gave all of this to us. We just had to plug in the amount, the initial amount, and the amount that's remaining. To solve this, we follow the same process. Divide both sides by 20, so we get the e by itself. And we have 12 over 20. Well, that'll simplify to 3 over 5 is equal to e to the minus 0.0047t. This is an exponential. Rewrite it as a logarithm. The log base e, or the natural log, of 3 over 5 is equal to negative 0.0047t. Divide both sides by negative 0.0047, and we'll have our answer. So I would type this into my calculator. Questions? Okay. I think we did this problem yesterday. Not yesterday, last class. Yeah, when we learned about matrices. Do we understand what this means? This 3R1 plus R3 put in R3? Maybe. I'm going to do it. 3R1 plus R3. Put it in R3. So that just means take row 1, multiply it by 3, add it to row 3. Put the result down in row 3. So, okay, 3 times R1 will be 3, 6, 9, line 12. Do y'all see how that's the same as row 1, just multiplied by 3? Then we're going to add it plus row 3. That's plus negative 3, negative 2, 1, and 7 with the line extended. So, okay, let's add these numbers together. We will get equals 0, 4, 10, line 19. And that's what we put in row 3. So we're going to copy the matrix. It'll be exactly the same. 1, 2, 3, line 4, 0, 5, negative 5, 1. But what we put in row 3 is the result from what we just did. Questions? Okay. The last thing they say is to do is take 1/5 times the second row and put it into the second row. Well, okay, the second row is 0, 5, negative 5, 1. Multiplied by 1/5, so times 1/5, will give us 0, 1, negative 1, 1/5. And then they said, put it into the second row. Well, that's great. We're just going to copy this exactly. The only thing that will change is in the second row, we put those numbers. So the new second row, instead of this, will be 0, 1, -1, 1/5. Questions? It gives you the step by step for this. Just follow it. This means row 1. This means row 1. This means where to put it. Okay. Solve it. All right. It's going to be a lot of what we just did. You know what, though? This one is going to take the longest. So I think I'm not going to do it. I'm going to come back to this at the end if we got time. Yeah, I'm going to come back to this at the end if we have time. But I think it's the longest problem that you will encounter. It's worth the same as the others, so we're not going to worry too much about it. Okay, write the solution. If you remember, this column is x, this column is y, this column is z, and this column is on the other side of the bar is the answer. So that first row says 1 times x plus 0 times y plus 0 times z equals 5. The second column says 0x plus 1y plus 0z equals -1. The third column says 0x plus 0y plus 1z equals 8. In other words, x equals 5, y equals -1, z equals 8. Does that make sense? Y'all see how I got that from this? Great. For B, it says x minus 4z equals 7. I skipped writing plus 0y, but do you see why that's true? Okay, so x minus 4z equals 7. Let me write it down below so I have more room. So I'll say, that was A, here's B. X minus 4z equals 7. And then y plus 6z equals 13. That's the second piece of information we have. The final piece of information that we have is 0 equals 0, which doesn't help us much, so we're not going to include it. So this one is x minus 4z equals 7. We would usually solve that for x. So we would say x equals 7 plus 4z. Y equals 13 minus 6z. And that's it. That's the answer. There's no other information, so we're done. A lot of times you'll see this written 7 plus 4z, comma, 13 minus 6z, comma, some z. Make sense? This one up here could have been written 5, comma, -1, comma, 8. Questions? Okay. This last one has a problem. What's the problem? It has no solution. Why? Because 0 is not equal to. Do you see how that last line tells us 0 equals 2? But clearly that's false. So this equation has no solution. So you would say C, no solution. Questions? Okay. Find the matrix. Okay, so we don't have to solve it, we just have to write it. All right. 3 volunteers stuff 864 envelopes. Okay? X could assemble 170, Y could do 121, Z could do 146. They worked a total of 6 hours. The sum of the number of hours that they spent, that Y and Z spent, was twice what X spent. How long did each of them work? Okay, here's what I'm going to do. I'm going to say X is the number of hours spent by volunteer X. And Y and Z are the same. Little y will be the number of hours spent by volunteer Y. Z represents the number of hours spent by volunteer Z. So I can write 3 equations. My first equation is if X stuffs 170 per hour, then the total number of envelopes stuffed by X will be this. 170 per hour times the number of hours, right? Plus 121 envelopes per hour times the number of hours that Y spent. Plus Z, let's see, Z spent 146 every hour times Z hours. That is the total number of envelopes stuffed. Do we see how I got that? Okay, the total number of envelopes stuffed is 864. That's my first equation. My second equation is that they worked a total of 6 hours. X plus Y plus Z is equal to 6. The hours spent by X plus the hours spent by Y plus the hours spent by Z is equal to 6. Is that okay? Finally, the sum of the number of hours that volunteers X and Z spent was twice what X spent. Well, let's see. The sum of the number, so Y plus Z equals 2X. Does that make sense? The sum of what X and Y spent is twice what, of what Y and Z spent is twice what X spent. This is nearly a matrix already. The only thing I have to do is rearrange that last equation. So these three are my system. The first two will stay the same. 170X, 121Y, 146Z equals, that's a terrible Z, that's okay, equals 864, that's the same. X plus Y plus Z equals 6, same. This last one will be negative 2X plus Y plus Z equals 0. So my matrix is 170, 121, 146, line 864. 1, 1, 1, 6. Negative 2, 1, 1, 0. Questions? Okay. Part B. You know what? It's going to be the same logic. I'll try and solve this at home and post the answer. But is it okay if I skip that problem? Same idea. We'll follow the same process. I think it's literally going to be 3 of the same sorts of equations too.
Just a question.
Yeah.
But at the end they ask how long did each of them work?
Oh, you're right. So they want us to solve this matrix. That is one of the things that takes oh, you know what? You can do it on your calculator. Google. Jenny, you know how to do it, right? What is the sequence of buttons? I can't remember.
You go to second matrix.
Second matrix? What button? Where is that button?
People need to have it like installed.
You do?
Not all calculators have it. Like I didn't have it.
Oh, so you have to install it. But you figured out how to do it too.
Yeah, just like in the math lab they do it.
Okay. In that case, I would say take it to the math lab and have them install it so your calculator can solve the matrices for you.
But it's second matrix. And matrix is like with a X, so 1 is like on the left.
Ah, okay. Well, Google it, take it to the math lab, but solve it on your calculator. That's the best way to do it. Okay. I'm just going to say solve on calculator. Is that okay? Y'all feel like you can at least, you either know it or you can figure it out? Hopefully. If not, send me an email. All right. Number 50, write the first 4 terms of the sequence defined by this. Okay, here's what you do. Plug in 1, 0, start with 0, Plug in 0, then plug in 1, then plug in 2, then plug in 3. So if I plug in 0, I get A0, A1, A2, A3. Those are the first 4 terms. If I plug in 0 to this, what do I get? 0 squared plus 1? 1. Then I plug in 1 squared plus 1, which is what? 2. And then I plug in 2 squared plus 1, which is 5. And then I plug in 3 squared plus 1, which is 10. Those are the first 4 terms. I just plug in 0, plug in 1, plug in 2, plug in 3. Questions? This is literally the same. You plug in 0, then plug in 1, then plug in 2, then plug in 3. Is it okay if I skip that one? Same logic, same steps. Literally this one too. Just plug in 0 and then here, I'll just do this one just to be thorough. A0, A1, A2, A3. Those are the first 4 terms. If I plug in 0, that's negative 2 to the 0 minus 1. This one will be negative 2 to the 1 minus 1. This one will be negative 2 to the 2 minus 1. And this one will be negative 2 to the 3 minus 1. Well, 0 minus 1, this is negative 1. Negative 2 to the negative 1 is 1 over negative 2. Negative 2 to the 0 is going to be 1. Negative 2 to the 1 is negative 2. Negative 2 squared is 4. Questions? You can do that on your calculator. Oh, we're so close. Find and evaluate this sum. Okay, the sum is the same as the sequence, just put plus signs. So you take this guy, 3k plus 1, and you first plug in 1. So it'll be 3 times 1 plus 1. And then you do plus, and you plug in 2. 3 times 2 plus 1. And then you do plus, and you plug in 3. 3 times 3 plus 1. And then you do plus, and you plug in 4. 3 times 4 plus 1. Well, 3 times 1 plus 1 is going to be 4. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 3 times 4 is 12, plus 1 is 13. When I add all of these together, I get 34. Questions? Okay. This is the same. I'll do it anyway. It'll be quick. So we do 2 times negative 3 to the, and then we plug in 1. And then we say plus. Here, I like to put parentheses around each one. Doesn't really hurt either way. In this case, it doesn't. Then I plug in 2. And then I do this. Oh, I made a mistake. No, I didn't. I start at 1. It says start at 1. That's good. Then I plug in 3. And then I plug in 4. So let's see. This is going to be 2 times 1. This will be 2 times negative 3. This will be 2 times 9. And this will be 2 times negative 27. So that's 2 minus 6 plus 18 minus, what's 27 times 2? That is 54. So let's see, if I add those together, that'll be 20 minus 60, negative 40. Questions? Does that process make sense? Okay. I am not going to do this one because it's the same. Plug in 3, then 4, then 5, add them up. Is that okay? You already got it? What's up?
It's different goals. It starts at 3 and then 5.
Yeah, it starts at 3 because they said started at 3, ended at 5. I'll write what this is. It takes no time at all. It's 3 squared plus 4 squared plus 5 squared. Do you see how I got that? Plug in the one that it says to start with and stop when you've plugged in the top. That's just 9 plus 16 plus 25, which is 9 plus 25 is 34 plus 16 is 50. I think that's right, but you can check. Okay, 2 more. We are almost done. A company charting its profits notices that the relationship between the number of units sold and the profit is linear. So if 200 units sold results in 3,100 profit, well, that means this. The profit for 200 units is equal to 3,100. And the profit for 250 is equal to 6,000. Does that much make sense? It says if you sell 200 units, you plug in 200 for X, you get 3,100. Here's the other thing that I know. P of x is equal to mx plus b. How do I know that? Says it's linear. Linear equations can always be written as mx plus b. Does that make sense? Then I can just solve it. So let's see. Slope times, if I plug in 200, I should get 3,100. And if I plug in 250, I should get 6,000. There's a lot of ways to solve this. Here's one way. Write it as a matrix. 200, 1, line, 3,100. 250, 1, 6,000. That's the end. You can put that in your calculator and solve it, and it'll give you the answer. It'll give you x, or it'll give you m, and it'll give you b, because this column was the m column and this column was the b column, and then you would have your answer. You'd just write P of x equals, plug in what you got for m, plug in what you got for b. Does that make sense? That's one way to do it. Here's a different way to do it. These 2 points are on a line. How do you find the slope if you got 2 points? Do y'all remember the equation for slope? The slope is equal to y2 minus y1, x2 minus x1. What's y2? It's the second y value. Do we see it on there? 6,000. The first y value is 3,100. The first x value was, or the second x value is 250. The first x value is 200. Simplify this, you'll have your slope. So that is 2,900 divided by 50, which is, let's see, that's just 290 divided by 5, which is the same as, hang on, I can do this. It's times 2, but then divided by 10, that is 58. So the slope is 58. That's what you would get, by the way, if you solved this matrix. You would get m equals 58. And then to find b, I just plug it in. I say, well, P of x is equal to 58x plus b. I don't know what b is, but I do know that P of 200, which is just 58 times 200 plus b, I know that equals 3,100. And then that's just a linear equation that you can solve. So 58 times 200, let's see. That is 11,600 plus b is equal to 3,100. And then if I subtract 11,600 from both sides, I get b equals negative 8,500. Which means, final answer, I will put it below both of them because you can get it either way. The profit function is 58x minus 8,500. Questions? Okay. State the slope and interpret it. The slope is 58. That means for every unit sold, the profit goes up by $58. Questions? I think we're done. This is, I think this is the same. This is the same. That's the one we just did. You can solve it basically the same way. Is that okay if I skip it? Okay. Y'all are very quiet today. Is there anything, we're done. That's the end of the last lecture. Is there anything you're uncertain about? You have any questions at all before we take a final exam on Wednesday? Do we all feel like we can do it? We know what's going on? All right. If you do come across any questions, feel free to send me an email. I will be watching out. I'll be answering as quickly as I can. I will